Okay, next we're going to move on to the motor effect. Now, to explain that, so if you look at this scenario, you have two magnets. They're not touching each other, but we know that when you have a north pole and a south pole, there's going to be a magnetic field between them. And you can see that, remember, the magnetic field always goes from north towards south. Okay, so you've got that. Now, between that, we're going to put our wire. So here's a wire, it's inside the magnetic field. And then what we're going to do is we're going to apply a current. So let's say this is plus and minus. So the current is going in this direction. Now, remember that if if a wire has a current going through it, that wire is going to have a magnetic field. So you've got a magnetic field of the wire, and you've got the magnetic field between the two magnets. Now those two magnetic fields are going to interact, and when they interact, it's going to cause the wire to move up, down, left, or right. Now we can predict which way it'll move by using Fleming's left hand rule. Now remember, you have to use your left hand to answer this. So to answer this, remember, left hand, your thumb is going to be the motion. That will show you which way the wire moves. Your first finger, your index finger, is going to be the pole. So this always aligns from north towards south. And your second finger is going to be the current. And this has to always point from positive towards negative. So in this particular scenario, you can see that north to south. So you can see it's pointing that way. And assuming that the current's going upwards like that, you can see that the finger is also moving upwards just like that. And as a result, you can see the thumb now will point downwards. So you move these two and you'll see where this ends up. So the thumb is pointing down, which means that in this scenario, the wire is going to move downwards. Now, not only can we predict the direction, we can also predict how much it will move by using a formula called F equals Bill. Now, what does that stand for? Force. So how much force the wire will move by is equal to B, which stands for the magnetic flux density. In other words, how strong the magnetic field is. I, the current, so the current again passing through your wire, and L is the length of the entire wire. So if any of those increase, the force will go up, and as a result, you will get a stronger force. Now remember that if the wire, the only time this will work is if the wire is completely perpendicular to the magnetic field. So if you got, let's say that you have your north pole here, so you got another one there, and your wire looks like this. So right now you can see that the magnetic field is pointing in this direction, north to south, and the wire is going that way, so it's perpendicular. So right now it will experience maximum force. But if the wire was going like this, for example, now you can see that the wire and the magnetic field are parallel. In this scenario, the wire would experience no force at all. So this formula, F equals Bill, can only be applied truly when the wire is completely perpendicular or 90 degrees to the magnetic field.
Hey guys, if that video helped you, support our channel by liking, subscribing, and sharing it with your friends. And more importantly, if you still have questions, drop a post on our forum at ExamQA.com, where I will personally be there to help answer your questions. Mohammed signing out. Hey guys, If that video helped you, support our channel by liking, subscribing, and sharing it with your friends. And more importantly, if you still have questions, drop a post on our forum at ExamQA.com, where I will personally be there to help answer your questions. Mohammed signing out.